the homework. So we're doing trusses. Now these things, they take a while, so be sure that you can work through these. And you'll need to spend a bit of time on these. They just take a little while to work through. So the homework was 292 and 294. So why don't we start with looking at these. Now, do we have any questions on these generally? What we want to do is work through these and solve for the forces in what are called the truss members, those long, narrow struts there that make up the truss. That's what we're doing. So 292. Now, I would like you to do it on 292 and fill in the answer blank down in the lower right. I need everything, all the answers listed in the order that I show there in the answer blank. Okay. All right, so how do you do a truss? Pray tell. Step the first is you find the reactions and the angles. Okay, so that's the first thing to do. So you treat the truss as though it is one object, and you want to find the reactions, at this case, at A and F. And you also want to do the trigonometry. Usually you use arctan, the inverse tan, to find the angles. So that would be the first thing to do. So do we got questions on that bit?
Could you go over when it's compression and tension?
Yeah, sure. We could have a look at a couple of these, okay? So what I would do on this, I do the arctans. I've got two of them. I've got one that a ratio of 1.5 to 2. That would be that angle CAB. And then and also DBE. And then also I've got another one that's a ratio of 1.5 to 1, which is angle DFE. So I get those angles figured out, and then I treat the truss as one whole object, and I find the reactions at F and at A. So sum of MA equal to 0 would be 15 kilonewtons, 2 meters clockwise, so that's negative. 60 kilonewtons, 2 and 2 makes 4 meters clockwise, negative. 2 and 1 makes 5 times RFY, so RFY is 54. And then sum of FY will get you the other reaction. RA is 21. Okay. And then sum of FX is 0, so that's RFX. Questions on that? Okay. So that would be the first step, is to find those things. All right, now once you've done that, you want to find a joint that has no more than 2 unknowns. Generally that is 2 unknowns that you're looking for, and known forces. So you could either go to A or F once you have found the reactions. So that would be the next thing to do, is look at A or F. Okay. So I went to F. Okay, so once I have the reactions, I'm going to go to F. What I have there is I have 54 up, that's the reaction, and I've got 2 unknowns, EF and DF. All right, so I'm going to go and what I'm going to do, I'm going to look at those 2 unknowns, EF and DF, and realize there are 2 of them in the X direction. Both EF and DF have X components. Only one of them has a y component though, and that's df. So I would solve the y equation first. 54 up, as I have it drawn down and to the right, sine, because that's the opposite side. So sine of the angle will get me that component, and I'll just transfer it over here. So the y component of df is down, sine's 56.3 times fdf. I can solve for fdf. That'll come out to be 64.9. When I do that, it's a positive answer, so it means it does indeed push on the joint. And then after I've got df, I can go sum of fx, set that equal to 0. And what I will have then is ef to the left, negative, plus cosine of the angle times what I just found df to be. So I'll get ef, 36 tension. Questions on that? So that gets me that one. Okay, now that I've found those two, now I can start moving through the truss, and that's how this works. I often like to mark what's happening in the truss. So that's 64.9, and this one is tension. So it's pulling at 36. So now I can go to another joint that has two unknowns and known forces. Okay. I went to joint E. Sum of fx will get me that BE is 36 tension. So that's pulling on the joint, so I mark it like that. And sum of fy shows me that the only unknown in the y direction is DE, so that's 0. Okay. And then from there, I can either go to joint D or joint B. I'll probably go up to D because it has two unknowns, whereas B has 3. So I'd go up to joint D. Okay. So we good with that? That's the process for these. Okay. So I'll go up to joint D. I'll do sum of fy, set it equal to 0. 60 down, sine 56.31 times 64.9 up, plus sine 36.87 times fbd, the unknown. So what I'm doing there, I'm using the sines, which are the opposite components, and I'm getting those forces, but I put them right at D. It's like I just slide them over from where I show them there on that right triangle. I'm using the sine because it's the side opposite the angle. So I'm getting 1 down 60 and 2 up, sine 56.31 times 64.9 plus sine 36.87 times FBD. I can work through and solve for FBD. It's 10 compression. Once I have that, I can go sum of fx, and I'll get FCD plus cosine 36.87 for times 10 for FBD minus cosine 56.31 times 64.9. So I got the positive ones are FCD to the right and the cosine 36.87 times FBD, which I know to be 10 now. The negative one is the 64.9. I can solve for FCD, and that comes out to be positive. Questions on it? We're doing all right? Okay. All right. So that's the drill on a truss, okay? And we just want to be sure that we get that procedure and that we're comfortable with it. Okay. So questions? Okay. All right. Why don't we find somebody that we could work with here, and let's just be sure we can do this. So let's head on over to page 17A, where I've got a picture at 291. So page 17A, do you have that? Okay, so there it is. So what are the first two things you do with that truss? Find the angles and what else? Find the angles and find the reactions. Why don't you just find somebody you can work with and see if you can get them. So find the reactions and the angles. That's the first step. All right, so find the angles and find the reactions. That's the first thing to do. I'll pause the recording so you could just work through online. Maybe pause the recording yourself, work through and see what you get, and then you can check in. So there are the angles, okay? There we go. Okay, reactions next. What are you doing all right with the reactions? Okay, so when you do the reactions, you treat the truss like it's one object, which is what it is, okay? So for reactions, you're just treating it like that. It's just one thing. So you want to find these reactions. Okay. Okay, we good?
Yeah, for that, it's a frictionless surface.
Okay.
So the only force applied here is minus force.
So once you got the reactions, then you start in on either one of the joints. You want a joint with only two unknowns. You could use either A or D, either one. Okay. Either joint is fine. Okay. So we get those reactions. And then you start in on one of the joints and draw a free body diagram of a joint that has a known force and only two unknowns. You can use either A or D. So that'd be the next thing to do, would be to go to one of the joints. Okay.
Oh, yeah, you did say that.
So you can do either joint you want. The way you start these is you write out the letter of the joint. Let's say D. Draw a picture. 6,000 up. I see CD and I see BD. So if that's CD and BD, I need an angle in there. And that is what, 26.6? So there's a free body diagram for D right there.
You just do it for each point?
Yes, they're called joints. Yeah, you work your way through. Now, you can solve that out. There's only two unknowns, so you can find the forces in BC and CD. using that free body diagram. You could do a similar thing at A if that's where you started. We good with that? Okay. Now, when you do forces, they got to be in a given direction. So it's got to be sum of Fx equals 0 and sum of Fy equals 0. That's the equations you write. Remember, we're doing vectors here. They act only in certain directions. So you got it when you write equations, you want all the x components in one equation, all the y components in the other. Okay? So we good with that? We got any questions on that? All right.